Hi, this is Robert from Part Fusion Electronics. About a month ago, I made a video where I introduced the SK6812 Mini E, this small surface mount LED, and I suggested that it would be quite easy for hand soldering. I wanted to take the idea a little bit further, and I came up with this LED pendant, and I kind of briefly described how I made it and how it works. So there's multiple brass rings with the LEDs mounted on them of different sizes. I'm getting power and control from an Arduino Uno here on the wire. It's not really a practical piece, more of a kind of a proof of concept for showing at events like Maker Faire. Taking the dimensions off the datasheet, I 3D printed these different types of jigs, one for holding the LEDs and the other part holding the brass wire. So some of the dimensions I was working on was trying to make it so that the LED would be supported and it's held in place, and then I can get access from the side, the bent legs for soldering. So the brass wire that I got was 0.8 millimeters. And what I did was I took the brass wire and using different sized markers and other cylinders, I was able to wrap the wire around and kind of make a spring like so. I would cut them and then fit them into the 3D printed mold and solder up these rings and get a nice fit. And then I also have a smaller one for the inside. So to get the rings as small as possible, I had to bend the legs. So what I ended up doing was holding the LED in a set of pliers and then just using my fingernail to bend the legs. Like that. So then the power and the ground leg are then protruding out. I just used regular lead-free solder, and it didn't flow very well when I tried to solder the brass. I then tried using like extra flux, just no clean flux, and this kind of generic flux paste, and the solder didn't flow very well. So I got quite ugly solder connections here. And what I found is, after doing a little bit more research, I found that if you use, this is basically plumber's standard plumbing solder. Once all the LEDs were soldered to the brass wire rings, I then had these LED leads that then had to be wired in series. I didn't have any brass wire that was very thin, so I just used this 0.35 millimeter tin coated copper wire. I ended up with something like this. So the wire is interconnected and there's a gap here where I would then have to bring my data signal in. I then was able to make up different sizes of my jigs, and it was the exact same process. Just had more LEDs to solder up. I just then had to make up larger rings and then solder up lots more LEDs. So then this was the result. I've got 8, 12 and 16 LEDs in series. The incoming connection goes here, the ring goes around, and then there's a wire interconnecting to the next ring, which goes around, and then to the next one here. I crudely interconnected the brass rings, so the outside rings are the ground, and then the inside is the positive rail. There's a wire here that just kind of gives it a little bit of rigidity in that plane. And then there's another interconnection here between the rings using the same tin coated copper wire. Plastic coated wire then was used to interconnect the positive rails and then to connect the LEDs in series. And then, as I said, I've got an Arduino up. This is a board that I made up just that I can use for easily connecting multi-devices when I'm showing them at events like Maker Faire. The process of 3D printing up a suitable jig worked really well. I need to tune my 3D printer a little bit more. I wasn't exactly happy with the Z height on some of my 3D prints, but it was close enough to be able to work. So if anybody has any suggestions for maybe other shapes, I could give them a go. I might try and do some maybe more three-dimensional sculptural pieces. Anyway, thank you. Bye-bye.